Good morning to all. Today we will discuss about the principle of homogeneity of dimensions. As you know that we have done yesterday about the physical quantity units and all about the types of the physical quantity, etc. So today we will discuss the principle of homogeneity of the dimensions. So what is the principle of the homogeneity of the dimensions? That the dimensional formula of every term on both sides of a given relation or equation must be same. So this is the statement actually of this principle of the homogeneity of dimensions. If we write it in or understand this fact with the some points, then we can write it as that number one, if we are having one side of the equation, that x plus y or x minus y, then they are only meaningful when x and y have same dimensions. It means we can say that x plus y, then x plus y, if we add y to x, it is only possible when the dimensional formula of x and y are same, or we can say x and y have same dimensions. Number two, if we write z equal to x plus y, then the dimension formula of z, x and y must be same, then this equation or the relation is correct. Number three, if any relation or equation having the multiplication or the division of a two physical quantities, the dimensions of the resultant quantity can be obtained algebraically as required. Means if two or more quantity are given in multiplication or division, then they can solve with the algebraic method and write accordingly. So using above points, we can use the above formula for different usage, and we can use this principle of homogeneity of the dimensions for the purpose of the to convert the numerical values of a physical quantity from one system of units to the another system of unit, and the second, to check the correctness or the significance of the given formula or the relation, and the third one, we can also use this principle of homogeneity of the dimensions to derive the relation between the among various physical quantities. And the fourth one is also that we can also check or determine the units of a given physical quantities if we know about the dimensional formula of that particular physical quantity. So now today we will discuss about the first use of this principle of homogeneity of the dimensions. As you know, or that any physical quantity contains the numerical value or the magnitude of and the unit, or we can say the quantity q is equal to nu. So n is the numerical value and the U is the unit. So if the N1 and the N2 are the two numerical values, and the U1 and U2 are the two units of the measurement of the physical quantities, then we can write that the N1 U1 is equal to N2 U2. So as we have seen the first equation, that the physical quantity is equal to Nu, it means N is the proportional to 1 upon U, or we can say that N is reciprocal of this unit. So N1 U1 is equal to N2 U2. And if M, L and T means M1, L1 and T1 are the fundamental units in one system, and the M2, L2 and T2 are the fundamental units of mass, length and time respectively in other system, and if A, B and C are the dimensions of mass, length and time in both the system, then we can write this above equation as N1 and M1 A L1B and T1C and equal to N2 M2 A L2B and T2C. So N1 and in bracket M1A L1B T1C is equal to N2 in bracket M2A L2B T2C. So as we can see here that if we solve this mathematically, this equation, then N2 is equal to N1 into M1 A L1B T1C divided by M2 A L2B or T2C. So we can also write this equation as N2 is equal to N1 and M1 upon M2 to the power A, L1 upon L2 to the power B, T1 upon T2 to the power C. Actually A, B, C are the dimensions of the M, L and T here, and this is the conversion formula to convert the numerical value of the physical quantity. One thing is we have to memorize or keep in mind here that we are converting here the numerical value of the physical quantity, not the unit, because as we have seen that the any physical quantity is uh, equal to n and u. So u is the unit. Unit is known in both the system, but the numerical value or the magnitude of the physical quantity is or can be converted using this method or this conversion formula. So we will we will solve some example or exercises of this formula in next class. So two formula and the two or uh, two usage. So, okay, we will try to solve the exercise related to this conversion of the numerical values of the physical quantities from one system to another system in next class, and the two usage which we have mentioned earlier, that to check the correctness of the given formula or the relation and to derive the relation among the various physical quantities. And if you can try to solve some examples related to this use, you can also solve. So please go through this principle of the homogeneity of the dimensions and the this conversion formula, so that you can solve easily and you can understand the exercises easily. So you can solve the one example, that 1 Newton is equal to how many dynes. So 1 Newton is equal to uh, how many dynes. So dynes given to you, but how many means numerical value or in CGS system so you have to calculate the that value of the numerical value in the CGS system. If you can do, you can exercise at home, otherwise we will discuss in next class. So thank you.